The tower and carriage of Detonator Bombs Away are made majoritively out of stainless steel. This is done because steel has a high tensile strength which supports the strain energy of heaving a large amount of weight up and down it fairly frequently. The tower and carriage of Detonator Bombs Away are made mostly out of stainless steel. This is done because stainless steel has a high tensile strength, which is good for supporting the weight that the tower has to hold. It is also a good choice because stainless steel is highly corrosion and rust resistant. The stainless steel's highly uncorrosive and anti-rusting capabilities are due to the mixture of chromium and steel, with chromium being a very unreactive metal that can either coat the steel as sacrificial protection or be part of the steel to reduce the amount that it rusts.
Now that we have seen what the ride is made of, let's see how it works. Bombs Away has 12 seats for the passengers. We sit on them, strap in and wait for the ride to begin. At the start, we are pulled up 35 meters in the air. When you have reached a peak, get ready to embrace the draw. Maybe even try rethinking some of your choices about getting on the ride. A countdown begins, and you let go. This is the section where you enter freefall, instantly accelerating rapidly until you reach 75 kilometers an hour, experiencing over 5G, and faster than it started, you decelerate until you are a complete stop. Now let's get into the science of it. First of all, we have the climbing phase. This is done by using a series of pulleys in order to decrease the energy used. The pulleys change the direction of the force, hence decreasing it. A pulley with 2 ropes, or in this case steel lines, and a wheel is used. The machine pulls on this pulley, its force is multiplied and therefore makes it much easier to pull. The brakes are a little more complicated. They use something known as electromagnetic induction. They do not rely on external power sources or batteries. They use magnetic brakes in conjunction to hydraulic cylinders. This is based on the electromagnetic induction we were talking about earlier and can be explained using Lenz's law. Each cart has a permanent magnet under the seats. Copper strips are mounted vertically in the lower third of the tower. When the cart starts to fall, it generates kinetic energy. This is transferred to the cart and induces the permanent magnets behind the seats. When they pass the copper wire, this kinetic energy turns into electrical energy. This induces an electrical current, which then in turn activates the brakes and creates a magnetic field. Lenz's law states that the magnetic field opposes the motion of the magnet, and as a result, the magnetic field pushes against the seats, causing the cart to slow down. The brakes are then used to slow it more until it reaches a final stop. This results in a reliable system that doesn't require any external energy.
There's first the electromagnets which Lucas talked about that are caused by the copper wire, but there is also some backup safety measures. Firstly, there's a traditional brake which uses cogs with teeth that will ensure the ride will stop. There is also springs at the bottom. If all the brakes fail or the steel wire snaps, the springs will absorb the impact of the carriage. Like many amusement rides, Bombs Away has safety bars to keep you in place, as well as seat belts to hold you in whilst you're falling. There are 6 cables holding up Bombs Away. These cables have been twined together to ensure even if one of the threads breaks, 5 others holding it up.